Alright, making a draft physics video. Making a draft physics video. Yes, it's a draft physics video presentation. See, my beginning is still disrupted by the fact that the stupid program, the screensaver, not screensaver, screen recorder, just the icon doesn't change when it's recording, and it's supposed to. And I have to fix that. I can't find where to fix it at the moment. Anyway, irritating. So everything is irritating. It's just the way it is. So I'll play a video by, I don't know, something that got 3 million views. It's sort of an overview of physics, and I'll just point out the parts where, they should have double checked that. They should have, and they're saying that wrong, and they're not really explaining what, it means when they say something like relativity. But anyway. Well, the truth is, it's just about this force stuff, the matter stuff, and the interaction thing. And that's all that happens in the universe is force stuff. This is a great background image, by the way. I mean, it's got the little force stuff, right, behind the little bits of matter stuff. It's pretty much, that's probably the future. That's the truth, is the little bits don't move unless there's a bunch of stuff pushing them. And that's just the fact. And such. So anyway. So there was one comment by some asshole defending yesterday's video, physics girl thing. Just some rag that starts with bro or whatever. The typical. They can't even do civil conversation in any kind of rational way. So you're just like, well, what kind of attitude are you expecting? And even if you're disagreeing with somebody who's hostile and obnoxious, the fact is you have to approach them just like you approach anything else. You have to show how to do it right if you're saying somebody else is doing it wrong. Two wrongs don't make a right, kind of thing. So they can't get those basics right. So they start off with this stupid bro crap. I'm not your bro, asshole. I don't like you. Okay, I think your music sucks. I think you're lame. Anyway. He's a musician, of course. All these artists out there, just all these artists. Anyway, so he's, her videos are obviously incoherent, okay, because they're tackling subjects that a third grader couldn't understand anyway. Way beyond their capacity physics-wise. So her lesson plan is stupid, okay? So if you're going to do something for 10-year-olds, then do something that's consistent for 10-year-olds, appropriate too. And if you're going to tackle the tougher subjects, well, then you have to tackle them in the right order. It only makes sense. You don't do math videos before you do simple logic videos. But anyway. And it's just this, what are you defending? The point I made is that it's crappy physics. It's not just that she's teaching it in this stupid, silly, fun, girly, creepy, stupid, unscientific way. It's not that she's trivializing something that's kind of important to get right and to be very explicit about, because that's what physics is supposed to be. It's about the evidence and coming to the right judgment. We really don't want defense lawyers and prosecutors in trials, to be in their jester suits, doing satire, doing, doing all kinds of bullshit antics. If the glove doesn't fit, you must quit. We don't really want that shit in a trial, do we, idiot? And this is the most important kind of trial you can have, is the trial of the evidence and what we should understand about our reality here. What the fuck we're doing here as little beasties, trying to figure out the right path in life. And part of understanding physics correctly is part of understanding your role here. And they're teaching crap. Okay, the fact is, it's crap. I've pointed it out. I've made it easy to see how their whole theory is made of crap. Crappy assumptions, the stuff they should have let go of 100 years ago, and they still are clinging to it. Their little wave-particle duality nonsense. Stuff that just beyond, it's so incredibly silly. Dark matter, for example, but relativity is still falls in that category. Silly explanations for the reality. They can't possibly be correct because they're so vacuous and empty. So anyway, I pointed out how one of her basic tenets of her physics is that the, matter has this perpetual motion thing. And one of the fundamental arguments is, well, that's not really the evidence. The evidence isn't that all matter does that. That you can throw an electron into space and it just keeps going, for example. Ugh, fuckheads. So anyway, just miss the point entirely and defend triviality and silly and fun and all of this horse shit that has nothing to do. Again, it's like, doing your little musical poetry thing. It's sort of a cheat of reality. Reality is to say, yes, your heart can get broken. Life is cruel. Maybe you should just say it rather than sing it. But anyway, fuck you. Alright, fuck this shit. So this gets 3 billion views from Lord Douchebag. This is the whole, these guys get to define what reality is for the masses. They're their source. And their source isn't, they don't have any credential. There's no real, where they've established they have seen through the veils and they have seen behind the curtain. They go to the wizard and they just sit there and say, well, it's a big flamey guy and he looks really angry, and, they have no clue, frankly. So, it deserves critiquing. So he's doing a map of physics. What is physics? And I will demap and point out that this is what physics is. Let's leave the words here so they'll get stuck in your head and you'll understand that this is really what you have to explain. He never mentions conservation of energy in here. The idea that, hey, you know what, it's weird about this force stuff, it seems like it just never stops doing something. It just moves from one thing to another thing, 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 to another thing. Hey, it seems like there's this stuff that just goes from one place to another place, and you can follow it along, because things will get hot, so to speak. You could watch it the easy way, and you just watch it jump from thing to thing, because the temperature changes. You could just watch the temperature change, and you could just watch it travel by watching the temperature change. And no coming close to that subject. That's not physics. Yeah. Really important part. Alright, where's the button? Here it is. Yeah.
So physics is a huge subject that covers many different...
Damn it. It really should be a little louder, right? Oh, I have to go through this crap. Oh, yeah, you fucking bastards. Alright, that should be more than enough. It's probably too loud, but it's better too loud, I guess, than too soft. Be fair to the retards. Putzes.
Topics going from galaxies in the depth of space right down to subatomic particles.
So, no, it's really just about the one subject, right? So that's another thing I should put on here in the screen. There's only one universe. It's the little one. The little one is where everything happened. The galaxies don't galaxy and, they tell the little things what to do. No, it's the exact opposite. The little things are telling the galaxy what it's going to look like. Just like you're made out of cells, and the atoms in the cells, and the electrons and the protons, and all of that stuff has to do something for you to do something. You don't do anything until it does it first. So everything happens in the little universe, and the big universe is in some separate place. It's exactly the same universe. The sun, in the space it's in, is the same empty space, so to speak, the same vacuum that the electrons and protons are in. Little universe first, and really only. If you want to understand physics, you don't waste too much time looking at galaxies. You spend some time looking at the atoms.
If you don't already know physics, it's difficult sometimes to see how all of these different subjects are related to each other. So this...
the really easy way to do it is to understand that the force stuff is momentum, okay, and it's moving the speed of light. and it will get converted. Okay, that stuff moving the speed of light will get converted into something solid, like a handful of cells and a handful of chemicals and atoms. And those chemicals and atoms will be pushed by a force, okay, and they'll move. And when they move and hit another pile of atoms, there's forces between the atoms, and those forces will compress like ping pong paddles and create higher pressure, which will push things more aggressively, and that'll force one hand to push the other hand. But that's the right way to understand it versus their wrong way.
I attempt to show that in a map. So this is the map of physics.
Right, so he does this map thing, right? I watched this video, so I already saw what kind of crap is in it. And it's really disconnected. And he says right in the middle of the video, oh, I should have said energy, and I should have put energy here and there. And then you're saying you went to all this trouble to make this graphic, and then you couldn't even edit it or something and say, oh, wait, I forgot to put energy in, so maybe I ought to go back and put it in. Yeah, maybe you should have done it right. you know, the first time. Maybe you should have done it a second time right instead of wrong.
You enjoy it.
So it's about enjoying. Okay, we all should enjoy being edified. Learning and becoming smarter and all of that stuff and getting right answers, and all that should be pleasurable. To say, eureka, I get it. I understand. So that should be enjoyable. But this shouldn't be enjoyable because this is misinformation. It's sloppy and trivial.
Physics can be broadly broken down into three main parts: classical physics, quantum.
So this is crap they should have just never done, is this whole idea of let's separate the truth into these stupid categories of truth and, like it says historical thing or something. We know round wheel works forever. We don't need to call it classical. It's just some things we have really right. And some things ain't so good, ain't so perfect. And all the modern stuff ain't so good. And a lot of the classical stuff is pretty reliable. But it's all one physics. There really isn't classical physics and quantum physics. There really isn't.
Physics and relativity.
Now, the distinction for relativity is like quantum physics. These are explanations without key elements are missing. So I pointed this out before, but their relativity, the gravity model of relativity, bent space, is a vacuous explanation. It doesn't account for anything real, force or matter or energy. So it doesn't have any energy in it. It's just some bending of space, right? So they evaded having to have a real mover. There's no real mover. So clearly they don't have to worry about the problem that would be drag. Now the joke is, the huge joke that no one even talks about, no one even mentions the joke, but the joke is when they teach relativity, they teach it as mock gravity, which is a particle theory, right? They teach it as it's essentially Lissage gravity, okay? They teach it as a convergence, okay? That means they call it an anti-divergence, which is really funny, but this is how they teach it. Okay, so if you go to a real expensive school and they're going to teach you relativity, bent space, they're going to teach it by telling you, well, it's like there's a constant source of water that flows into the universe, and there's a little drain inside of every little piece of matter, and the water, like going through, it's a constant pressure, so it's like water going through two pieces of glass. And so it's a constant pressure, and it just goes right down the drain. So there's a constant source of new water. It goes right down the drain. And everything that's floating around in the water moves with the flow. So they teach it as if there was an external high pressure, right, out here, and an internal low pressure, that is a hole, inside the matter. So it's exactly as if there were particles on the outside of the universe constantly hitting something and pushing everything together. So it's exactly like the particle model in the sense of how they actually teach the subject as a convergence. Now obviously the particles don't fall down a well. What happens is when they go through the matter, right, when a particle, a piece of energy, force, goes into the matter, it's slowed down a little because when it goes into the big piece of matter, the Earth, we know that the Earth is made out of electrons and protons and all that crap. And what it actually does is that force hits one of those things and pushes it. And while it's pushing it, it's moving a little bit slower. So it loses a little tiny bit of its energy. So when it comes back out, it comes out a little late. All right? It's slowed down. And we know that its momentum is based on how much distance it travels in how much time. So it's going to travel less distance in the same amount of time. That means it's actually lost some momentum. It lost momentum in here. So what goes in, less comes out. And that means something over here that's between two of these things, let's say, and one of them doesn't do that, then obviously it would move in towards the one that does, right? The one that has the lower pressure. So it just creates lower pressure out than the pressure that went in. And obviously that would explain gravity. It's a real thing, not a fake thing, not a bent thing. But the trick is that once you create that field, then you have to explain drag. But drag can be explained because we know electrons and protons experience it. So we know that atoms somehow can evade the problem of drag. And it has to do with what neutrons are doing with protons. And so it's a little more complex, but yes, there is an explanation. It is understandable. But they evade having to explain it by creating this fake water that doesn't really exist in the universe, right? See, their theory, they'll never talk about how, well, what about when you're flying through the water? And wouldn't the water slow you down? Well, they don't have to, because it's not a real, it's an analogy. They're not saying there's any real water. They're just saying this is what it acts like. You know, so it's more of this, it's sort of like, and that's as good as their physics gets. It's sort of like, but I can't give you a real explanation, because if I give you a real explanation, I have to account for the consequences, and they can't do that. But that's the big joke of it. Relativity is really a particle theory when they teach it.
Start with classical physics, and a good person to start with is Isaac Newton. His laws of motion describe how everything made of matter moves about.
So again, it's just wrong to say everything made of matter. So they always do this. They say electrons, protons, photons, it's all the same thing. It's like with the two-slit experiment. They imply that it's all the same thing. It's all doing the same thing. They're all behaving the same way. They're all following the same rule. No, they're not. It's fundamentally different. And the laws of motion are only true on a certain scale. And when you get to the atoms and you get to the frickin' subatomic particles, all of a sudden the same laws don't apply. They're not the same rules. And it's just wrong to say that they are. Electrons don't do what baseballs do, and photons especially don't do what baseballs do. That is, acquire another motion. Okay, well, you can't put a photon on a train and have it go 90 miles an hour and then throw it, backwards and have it go 0. I mean, it can't acquire two different momentums.
And his law of universal gravitation tied together the motion of planets in the sky with the falling of objects on Earth.
Right, and this is another huge mistake, is to understand that it's just a force. And so he's describing one of the forces. Gravity's a force. It's one that moves at the speed of light. The force you apply, again, when you compile a bunch of atoms, so it's all ping pong paddles and ping pong balls, you could understand, right? So you can understand if you have a paddle and another paddle and the ball's bouncing back and forth, there's going to be a certain number of hits based on the distance. And the closer I make the distance, the more interactions there'll be with the paddles. And each interaction means go this way. So you can sort of understand that you can compress a bunch of this force, in atomic structure. So if atoms are here and I push on another set of atoms with paddles over here, you can understand that the pressure of these paddles will push on these paddles, compressing their thing, and that'll transfer energy from one set of paddles to another set of paddles by the same little balls bouncing between them. And so I can convey the force by having the force jump between the paddles. Essentially, the pressure, the amount of proximity by moving the paddles. And that's how energy moves through atomic structures. It's going through the paddles. But if you were just to see the energy, just the ping pong ball traveling through space without hitting a paddle, well, it's just a little quanta of energy, a little piece of momentum traveling at the speed of light. And obviously when it has to do this transferring thing, that is, it has to move paddles, it always moves the paddles a little slower than that. So it's always diminished a little by having to move a paddle.
One elegant and general description.
And it's not all that elegant.
He also invents calculus, a supremely powerful mathematical tool.
So supremely powerful, all this, this way exaggerated stuff. All calculus this is allowing you to do is to take something that happens over time, something that has some sort of regular pattern to it usually, and you can make deductions, you can make generalizations, and therefore you can predict outcomes over many permutations, or a large amount of time by taking a little segment, a little segment, a little segment, averaging. So it's just a way of averaging something complex into little pieces, and the inverse, taking something that's a big thing and understanding it as pieces. Not an unuseful thing, but I'm just saying it's just not magic.
Which has been used over the centuries to drive new physics. Calculus is really a part of mathematics.
It doesn't derive anything, so that's more, nonsense. Everything's made out of components. Everything's made out of a process. Nothing happens spontaneously or instantaneously. These are bullshit words. They don't have any meaning in the real world. Like random, there's no such thing, really. And so all of these are just fake words and fake notions. So everything is made out of process. Everything is made out of a process of having to push little paddles around. And that's the facts. And you can understand that something that happens over a long period of time, over thousands or millions or billions of paddles, has a pattern to it. And you can see patterns.
But physics and mathematics are inseparable.
No, they're really not. So this is just more nonsense. You don't need mathematics. You can draw pictures, frankly. A picture, it can be worth 1,000 words, and it can show you. I can show you a circle, and I can cut the circle into pieces and show you that where pi lives. Okay, in terms of I can show you what it is that makes this mean something. This relationship between this distance, or even this distance, and this circumference. And I can show you, oh, well, this relationship is this. Okay, this is your piece of the pie. Okay, and so you can understand these relationships. And so it can all be understood as a picture. You don't need to do mathematics. But the point is just understanding relationships. You can understand that something has a velocity. You can understand that if it hits something and it bounces off of it, and then I put another thing over here to hit, that it's going to hit again and again and again. And the closer I bring them, the more they hit. And yes, you can write an equation to describe that. But I can just draw the picture. I can show you.
Maths is the language of physics, and you can imagine it like the bedrock.
It's just the language of relationships. It's a formalization of the variables that cause the effects. So you find out what the relevant pieces are, and then you can just put them into mathematical formulations. You can just say, well, this radius is an important variable. You can change that. And it has a relationship to how long this line will be, this piece of the circumference. And so it's just a relationship that you can understand and that you can formalize. And that's really going to be deciding, this will always be decided by this distance. But it's not, again, it's not, they make it into some sort of, as if the universe is mathematical, when it isn't. It's not made of math, it's made of relationships. And the relationships really are just about distance.
That the world of physics is built from. Newton also made strides in the field of optics, which is the physics of light and how it travels through different materials. It explains refraction seen in prisms.
So it doesn't explain anything. So let's understand. Newton didn't explain any of that stuff. He said, I'll tell you what happens. I can't tell you how it happens. So again, that's just wrong. He did speculate about some things like refraction, but he didn't have a great explanation. He conceded that. So again, it's just more crap. They say something that just really isn't true.
Lenses, which are used to focus light in telescopes, microscopes, and cameras. Telescopes enabled us to peer into the depths of space and observe the wild array of objects there.
Yeah, and it really doesn't. It's not. Again, it's not very interesting in terms of understanding physics. There's just you're looking at big objects in empty space again. The complexity comes with cells and the complex compounds that can be formed. And obviously there's just elements mostly in the universe. It doesn't do a lot of compound stuff. Okay, now on the surfaces there can be some compounds, but basically it's just elements and clumps. And so it just isn't that interesting, frankly. It's not going to tell you that much about how the physics, okay, the dynamic of force and matter interact.
And developed astrophysics and cosmology. Optics is closely related to the theory of waves, which is basically...
So again, it's the theory of ether. So let's understand Maxwell. All these people were etherists. They believed in jello, whatever. I don't know why. I had just this escapes my capacity to do reasoning why anyone would think the universe out there, that black stuff, has to be made out of something. Why they think it has to be made out of, I just don't understand it at all. Just don't. I don't know why you think something has to have, something is made out of something else. Why does it always have to be something else? Why can't there just be basketballs and hoops? Why does it have to be something else?
How energy can travel through disturbances of a medium, like ripples on the surface of the water.
Right, and the medium is undefined. This, they'll never say they're etherists, but they are, and so they just play this fake game where they don't talk about the very thing that's the core of their whole philosophy, is this idea that these mediums exist. Medium. And they just call them fields instead. And he never says the word field in here anywhere, I don't think.
Or sound through the air. Light doesn't need a medium to travel through. It can travel through the vacuum of space, but it still follows the same principles as...
Right, so it's the same principles as a wave in a medium, and yet it's not a medium. I mean, it's just, what the fuck is that baby talk? I mean, that's just such crap. Why, how do you get away with that? I mean, how do you get away with something so overtly stupid as to 1 minute say it's a wave in mediums and then say, oh yeah, but light doesn't obey those rules. It just looks exactly like it, except it's not the same. I mean, it's stupid, and clearly light doesn't behave like a wave, and that's demonstrable. So all of this nonsense about light being a wave is just that nonsense.
All waves, namely reflection, refraction, and diffraction.
So again, those are all just deflections. Okay, they're all changes in direction. That's a key point. All right, that's all they are. And they're making a claim that these are all wave phenomenons, when no, they can clearly be understood as pool ball kind of analogies. You can use just as well to explain the different ways that a pool ball can bounce off of something, can reflect, it can cause other things to deflect. So all of them can be understood as just interactions between particles and has nothing to do with frickin' waves.
Leads us to electromagnetism.
It really doesn't. Electromagnetism is about straight lines. If you really look at the math, that's all it's talking about, is straight line vectors of energy, force, momentum, period.
The description of magnets, electricity, or more generally, electric and magnetic fields.
So they draw this typical little field lines without the underlying mechanics, which is straight lines from this object, straight lines from this object, and it's just telling you where you have the same amount of pressure between the two vectors that you end up drawing. And these are just equal pressure points. And this is what either a monopole or a dipole will do when you put it in the field. In this case, these are, these are drawn so poorly. These are magnetic drawings that draw like charges. but frankly, they don't look exactly the same. So here he's done drawing charges here and magnets here and gave them the same appearance, which is just wrong.
It was a physicist called James Clerk Maxwell who discovered that these are two aspects of the same thing.
All right, so that's true. Okay, they're one aspect of one thing. Okay, and he didn't do that. He created two different fields, a B field and a whatever they call the other one, an E field, B field for magnetism. Strange, but anyway, so in a sense, he just said, okay, they're the same thing, but they're not the same thing. See, that's where it all goes kind of south. The field is actually one field. You either change it or you don't change it, and there's two ways to change it, through electricity or magnetism. But you're just making the same field in the sense that you're just causing an electron to go away or you're causing an electron to go towards. And that's all charge really is.
Derived the wonderfully elegant rules of electromagnetism and theorized that light was an electromagnetic wave.
So again, he just compiled other people's mathematics into a new mathematics that was a little more streamlined. So again, it's all this grandiose stuff, but he didn't really invent anything. His addition was slight to all the other guys' work, Ampere and Coulomb and blah blah blah. And so, that's sort of an exaggeration, but this idiotic drawing of a light is silly. Light is just clumps of momentum at a frequency, and clearly the polarization of this they don't account for. Huge polarization. They ought to draw this and say, oh yeah, it's 2,000 atoms of humps here, 2,000 atoms worth. Big giant thing as it moves through space in one dimension. It's huge. They don't talk about it. Facts don't matter.
Electromagnetism also explains all of electricity.
So again, just more nonsense. All of, I don't explain anything. You don't even have plus and minus assigned correctly. So they should point out that yes, we've kept a theory where we assign the place that has an excess of electrons. We've misidentified it completely upside down, and therefore we have current going one way through a circuit in our math and voltage going the opposite direction, because we have mislabeled the element that we're analyzing. So they didn't even fix it. Huge mistake, didn't even fix it.
Jumping back a little bit, classical mechanics is related to Newton's laws and covers...
So again, he's going back to the same subject he's already in. So this is already in the classic mechanics subject. And then he says, well, going back to classical mechanics, what sense does that make? Either it is or it isn't. And again, this whole word classical is stupid. You ought to just say the stuff you can be certain of. And the fact is the very nature, the very Maxwellian wave-particle duality nonsense that is raised by Maxwell and by other experiments 200 years later, says that this is part of the unknown mechanics from your perspective. From their perspective, this is the unknown mechanics, because they can't figure out the difference, that it can't be both a particle and a wave. It's just a silly, non-formed, it's like saying it's a dinosaur and a butterfly. It can't be both.
The properties and motion of solid objects, how they move when forces hit them, and what happens when they are joined together, like in gears or in buildings.
Right, but they don't really get to the really complex part of those equations, which are kind of illustrated in a gyroscope, because there you see where the forces really get confusing, because there's a bunch of atoms moving in circular motion, but they're also being tied together so they can't fly apart, so they can't go where they want to go, so there's all kinds of tension, and then it all focuses on a fulcrum of the bearing. And the fact is the bearing is going to transfer energy in one direction into energy in another direction. And that's what happens with all of these different kinds of mechanical systems, is you're just saying, where does the energy get transferred? And that's all you got to look for, is where the transfers in direction.
Bridges. Fluid mechanics is the description of flows of liquids and gases. Using fluid mechanics, you can work out how much lift is generated from an aeroplane's wing, or how...
I shouldn't even brought that subject up, because again, that's another one that's got so many nuances to it in terms of what's causing your breaking molecules. You're also creating some ions. You're creating electrostatic effects. There's buoyancy issues. It's very complex. what exactly is causing lift on a wing. And so it's just kind of funny, that's a part of physics that isn't so well defined. It's got there's a lot going on, and way too much for them to say, oh, this is how simple it is. No.
Aerodynamic a car is. Fluid mechanics is notoriously difficult, mostly because the motions of tiny things like molecules get really complicated really fast.
Right, but what makes them complicated is the fact that you haven't figured out your wave-particle duality thing. You haven't figured out that the atoms aren't made of a bunch of electrons orbiting protons at 400,000 miles a second. Lots of things that you have wrong, and having those pieces wrong means you can't really follow the bouncing ball at all, because you don't have one. You have some notion of a generalization.
Which leads us to chaos theory. Chaos theory
is silly defined, it's stupid, it's an idiotic concept to even talk about. There's no such thing in the universe. Again, it's another nonsense word. It's like saying spontaneous theory, or random theory, or instantaneous theory, or, well, instantaneous is okay. These are words you shouldn't even use in physics. And the word chaos is a nonsense word. There's no such thing as chaos. There just isn't. Okay? You can't make anything called real chaos. There's no such thing.
It's the description of large, complex systems and how small differences in initial conditions can lead to very different final outcomes.
Right, so you're making something, a recipe, you got to follow the recipe. You can't let the glue dry too slow or too fast. You got to do things in the right order, blah, blah, blah. And you do things in the wrong order, you're going to get a mess. Your outcome isn't going to be what you expect. You make your light bulb and then try to put the filament in after you made the light bulb. Well, you're not going to have you're not going to have much luck cramming it in there.
Thermodynamics is the description of energy and how it passes from one form to another.
So the description here now for the first time uses the word energy, okay? And so this is, everything is a kind of thermodynamics. Everything, because it's just the idea that they only consider one kind of energy meaningful. That is how fast molecules are moving or vibrating or banging into each other. And really the energy is in every tiny bit of movement. Every time something moves, okay, that's energy. That's where you're actually consuming energy in the universe. That's the irony. Energy is where you're consuming energy. As funny as that sounds, right? Because the place where we say here's energy is gravity. And really, what is gravity? Gravity is a lack of energy, as I just pointed out. Gravity is more stuff goes in than actually comes back out. Okay, and that deficit is what things fall into. So energy is where you make things fall into a deficit where you've consumed energy by slowing forces down, by causing them to interact and have to push on matter and move it. Moving matter consumes energy in the universe. So if you can put matter far away from each other, where it doesn't interact very often, doesn't hit, you don't have the ping pong ball paddle thing happening. Less energy is getting used, and that means there's more energy available to be used.
Includes entropy, which is a measure of order and disorder, and basically tells you how useful different kinds of energy are.
So again, there's only one kind of energy, and so you're just creating high pressure and low pressure by diverting force, and that's it. Using the force or changing its direction. But suppose it's valid enough to talk about entropy, but to understand it in any other sense, that all entropy is really saying is that if the bigger I make the universe, the colder I make it. The smaller I make the universe, the hotter I make it. I mean, it's not much more complicated than that.
Energy is a fundamental property to physics.
Right, so what he should say is force. So force, matter, interaction. So force is The matter is important because if the matter doesn't if you don't have the matter, the force can't interact with force, and so nothing happens in the universe. You don't see any change, and so matter allows there to be change because it's converting some of the momentum of the force into the distance created between the bits of matter. So to compress the ping pong paddles so you can have more interactions requires you to have more interactions pushing the paddles together. I mean, that's the conservation part of it. You need pressure to make pressure.
So I've written energy here. I should have written it everywhere on this.
Right. So then why didn't you? Why didn't you fix that? Why didn't it's 3 million views and it's completely wrong because you really missed out on the most important thing happening in the universe, which is the transfer between force and matter. The fact is that interaction is energy. You don't know the universe exists or that something's going on in it until little bits of force hit little bits of matter, and that interaction causes the matter to move when that consumes a little bit of the momentum of the energy, the force.
Map, because everything is energy.
So again, that's really not saying it very accurately. Everything is energy. It really isn't. Okay, there are pieces to what makes the formula. I would argue the force, if you want to use the simple term, that's the source of the energy. Okay, and the matter's just a victim to it. The matter's just being, it doesn't do anything until it's forced to do something. It always has to be forced. It doesn't move from point A to point B until the force acts on it and tells it that's what you have to do because there's more force on one side of you than there is on the other side of you.
So that's all of classical physics. The picture of the universe we had around the year 1900.
So again, it's the picture they had in the 1600s, so 1720 anyway. Maxwell is the only thing that's, there's nothing older than him in here that he described that wasn't well understood, or substantially understood.
He told us we lived in a universe where everything ran sort of...
So he uses gear works when he really is saying that all this is wavy mush. Gears aren't waving, okay? Gears are kind of, very discrete, very precise. Nothing arbitrary, no spread out kind of stuff, none of that kind of nonsense. Oh, squirrel by the window. Anyway, squirrels I learned to appreciate them, watching them. They're very much alive, they're just always looking, always figuring out, always, thinking. What do I do? What do I do? What do I do? I got a nut. What do I do? What do I do?
Could measure everything accurately enough. The future was kind of predetermined.
Yes, we do. That's exactly the truth of it. And they didn't know that. Maxwell was a religious. All these people were religious kooks. Newton was a religious kook. So get real. They didn't believe in his clockwork crap. They didn't really have a good understanding that everything that's going on is robotic, that it's all determined, that, you can't evade the causes and the effects, and there's just nothing in it that's magical. You need these little force bits to do something, to screw up your brain and your psychology. It all gets screwed up by blood vessels have to break and has to destroy memories and has to create fake memories, and all this stuff has to actually physically happen. And there's just no magical demons or gremlins or spooky bits in any of this crap. And they didn't even know that then, okay? Because they're still religious kooks. So let's not assume that classical physics means clockwork physics. The irony is that Einstein is the one who brought it up. Einstein's the one who was pushing the idea that, if you have enough information, we can dissect anything and figure out exactly why it happened. Because there's a trail. It's all got a blood trail. Little footprints of force are on it all. And that's the irony. Einstein understood that, and yet he proposed a theory that was vacuous, and he let them glorify it as if it was a piece of wonderful brilliance, and it's an evasion of physics. It's an evasion of having to have an actual force.
However, not everything was solved. There were just a few holes in experiments that hinted at something.
Yeah, tiny, tiny little irregularities and little spooky bits that fooled people. I mean, if I went back 100 years ago and took my little ferrocell with me, right? A ferrocell, I don't have one. Well, I made one for a microscope anyway to find out how it worked, but that was it. Because it's a toy. But if I took it back to 1900, people would be mystified and be, oh, look, light bends, look at that, blah, 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 blah. You know, it's a trick. So there's little tricks we hadn't figured out yet. The magician still was confusing us with his little rabbit out of the hat trick. He had some pretty good tricks that were pretty hard to figure out. And you're just coming up with explanations that are just damn silly. So yes, you see the pigeon pop into his hand and you're saying, oh, he must have made pigeon. You know, he must have like the heads of pigeons over there and a tail over there, and he made a pigeon.
The orbit of Mercury was slightly too fast, and some strange things happened on the smallest scale.
So again, the strange thing is you think this big giant thing, this thing with a polarization of 2,000 atoms, is somehow interacting with a single electron, which there's just no chance in hell that it's doing that, okay? One of these blobs cannot interact with one of those little blobs. Just can't happen that way. And the Mercury thing, I've explained that all I have to do is move the center of the sun's gravity a little tiny bit. Just move the center of the gravity a little tiny bit. Process the sun's gravity, the sun's center of mass. Just process it a little tiny bit, and I'll explain Mercury's precession. And that's all Einstein did. He came up with a gimmick that basically just does the same thing as me imagining the sun's precession. If I imagine the sun to precess, that is, you don't even see it on the surface. It's happening inside. A little bit of its mass is heavy in the center and it's just wobbling a little bit. Then you can explain Mercury. So it's not that out of the woods kind of, wow, there's no way to explain it except by coming up with some wacky theory that space is bent and time is warped. No, and that time is a dimension of some kind that you can change. There's no changing time. It ticks, tick, tick, tick. And it ticks based on one clock. And the clock is, there's no such thing as instantaneous. That's the clock. As soon as you make things happen slower than instantaneous, the clock is ticking. And the fact is, the fastest thing we know of is moving slower than instantaneous. So there is a universe and there is time.
With electrons and light, which were all unexplained.
It wasn't all unexplained. So, but the point is that obviously Newton couldn't explain it because he didn't have the knowledge that we do have about the fact that there's this atomic structure. But the fact is your knowledge of it is with this, orbiting electron that doesn't have a position and Heisenberg and all that kind of nonsense. But the fact is that you haven't analyzed your experiments very carefully, and you've just jumped to wacky conclusions like the double slit. I've debunked it. I've shown what it's really made out of, that scattering photons completely explains the pattern. You don't need any wavy, wooey bullshit. No wave functions, no probability functions. All of it's just a bunch of nonsense.
Physicists at the time thought that they'd solve and explain these problems soon enough, but poking at them, they unraveled the new domains of relativity and quantum physics.
So anyway, this whole thing, they unraveled the domain. And no, it was a stupid Eddington experiment that was a piece of garbage. That you said, okay, Einstein must be right because he predicted that light is bent twice as much by gravity. Now, you haven't redone the experiment. You haven't done it with better technology. You haven't done it from space. You haven't in any way verified it as information, as a truth. All the images from space of the galactic lensing is garbage mathematically. It doesn't make any sense mathematically. It doesn't follow any of the frickin' physical rules. Therefore, you invent dark matter, this made-up ghost that can sit there and create one thing and has no other consequences. Again, like relativity, like bent space, it's a magical way of doing physics. Okay, it's a magical thing that doesn't have any energy. It isn't a real thing. And you don't have to account for its existence in any other way. It just makes magical gravity. It doesn't do anything else. I mean, it's just silly explanations. So these two mistakes of the 1900s are just silly explanations. This wooey, magic ton, wavy nonsense, and this idiotic notion that there's a force made out of bent something. And you can't bend anything in 3 dimensions. So it's really just saying there's a little vacuum cleaner inside of every single piece of matter. Every single piece of matter has a little vacuum cleaner inside of it that just keeps sucking the magical suckable. I mean, it's silly as an explanation.
And our understanding of the universe completely on its head.
And it's just, yes, you put logic completely on its head. I'm going to just break all the logical rules, and now I'm just going to say, instead of God, it's Lord Gremlin. Okay, that's all they do. Instead of, they're just redefining the magical force and just calling it a rabbit instead of a squirrel.
Albert Einstein was the genius who developed the...
So again, this is, blah, 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 blah. He was, whatever. He's a tragic figure in this whole thing in a way. Okay, I mean, you show him no respect in the sense you say he's a genius, but we really don't mean the last part of his life he wasn't a genius because he opposed everything we were talking about. All the things we put his name on that wasn't his theory, like gravitational waves. So you break this statement all over the place. You say Einstein was full of shit, most of his life.
Theories of special and general relativity. Special relativity predicts that the speed of light is constant for all observers.
This observing thing is just so idiotic because we observe at the speed of light. We observe something at the speed of light. We don't observe it instantaneously. So what's the point of even talking about observation? It's irrelevant. The fact is the speed of light is the same everywhere, all the time, forever, always. It's just never changes. It's not about observing something at the speed of light. It's about what is it doing. And things do actually, the light always travels the speed of light, always covers distance at exactly the same speed. It goes from here to here at always the same speed, no matter where I put it, no matter what frame it's in, no matter where it is, it always moves exactly the same speed. Because guess what? It's a force. And all you can do is capture it. You can trap the force and then release the force, but you can never change the speed of the force. So, I mean, it's just this simple. I mean, it's this simple, and I have to do all of this work to sit there and persuade you that there could be an alternative understanding. It's just so obvious. So obviously I could have some system of matter, and I could trap light, force. I can have a little bit of force that's bouncing between, say, 2 electrons, and I could be doing that for 1,000,000 years, and then I let it go. And if I let it go with other partners, that is, there were partners at a frequency, and you could understand you could let it go at a frequency, okay, the frequency of these objects. I could just remove this object and you could understand they'd all come out at the same speed because they've already achieved a resonant frequency. But the point is that this speed is always the same. I can't make it go faster. I can't move this in this direction and give this extra speed. You can only release it. You can only hit it here instead of hitting it here. Waiting until it gets to here. You could do that. You could wait till it gets to here. Or you could move this and hit it here at a new time, and then it's going to leave sooner because you moved the thing it was going to hit. But this never changed speed. This thing never changed its speed. You just released it sooner. That's it. So this can never be given more momentum, and you can never give it less momentum. I can't move this way. That just means I hit it later. So it leaves later. That's all it means. But you never change the speed of the force. The force can't be changed. And Einstein didn't say anything different than that, frankly. Einstein didn't disbelieve that. They're just turning Einstein's words into saying, because you perceive it different, because you can be moving, and you could be moving relative to something else what's happening, that you'll see it wrong. Yeah, you can see it wrong. The seer doesn't make the truth. I mean, Einstein was making that kind of clear when he pointed out the moon doesn't disappear when I stop looking at it.
It means that when you travel really fast, weird stuff starts happening.
So it really doesn't. There's no weird stuff happening, okay? It's all sensible stuff. When you start moving, you change the universe. As you're moving, things are going to happen at different times than they would have happened if you weren't moving. The stuff coming at you gets to you sooner. The stuff behind you gets to you later. Just a fact.
Time slowing down.
Now, there's no slowing down of time. So this is another, just a coincidence. It just turns out that decaying nucleuses, radioactive elements, decay slower when you give them velocity. And it's perfectly understandable that if decay was being caused by some environmental condition, and that they already know is the truth, right? If I want to take, I can have uranium, and let's say its decay, its half-life is 10 million years or something, 10,000 years. I can change that number by just putting it next to another uranium atom. I can put more, I can consolidate the atoms and increase the rate at which they decay. So clearly the decay rate isn't something that's happening from inside of the atom. It's clearly happening from something caused by the environment. So if I put radioactive elements in a radioactive pile, their decay rate will change. They will decay much more rapidly. So clearly it's affected by environment. And so why is it so unintuitive that obviously, there might be a correlation where you could slow the rate of decay down by accelerating radioactive particles, therefore changing their environment, meaning they're getting hit by more force in the front and less force in the behind, and therefore the event that causes decay is less likely. You reduce the probability of decay by putting them in an unbalanced force. You have more force on one side than the other side, you change the likelihood of this decay event. So that's understandable. But it's just a coincidence, and that coincidence is they say is this huge validation of the theory, and it doesn't really prove that clocks change how they function. It doesn't, they haven't shown us a pendulum clock slowing down. They haven't shown us a sundial slowing down. They haven't shown any other clock except one dependent on radioactive decay slowing down.
It also states that energy and matter are different aspects of the same thing.
Well, see, that's just silly too. Energy and matter are the same thing. I could say that matter could be made out of dead energy, photons that aren't moving anymore. I could make up some crap like that, Why bother? We know they're distinctly different, and the force has the momentum, and the force is moving really, really fast on its own all the time, and it never stops. The little BB never stops moving, no matter where it goes. It's always, you can trace every bit of movement to some previous movement, Every cause, every effect can be traced, and what you're tracing is the force. The matter is just a victim. So there's no point in saying this is all the same thing, because it's the difference between the ping pong ball and the ping pong paddle. That is all the difference. That's the only way you can have the interaction. So again, this is just throwaway garbage. They say this crap doesn't mean anything.
Famous formula, E=mc².
Which is really just saying that matter traps energy. That's what atoms do. But there's nothing intrinsically, there's no energy intrinsically. If I take this formula seriously and go all the way down to an electron, the electron intrinsically has no energy. It's got nothing on its own. So without being associated with other paddles in a complex arrangement where you've confined space and distance and created more pressure, there is no mc². The elemental bits don't have any mc² energy. They only have it when you force them to be part of atoms.
General relativity says that space and time are part of the same fabric called space-time.
Which is just absolutely nonsense. The fabric, it's a three-dimensional universe. This fabric analogy is just so immature and incomplete and unsatisfactory. So again, if you're going to make it real, you have to do it in 3 dimensions, and if you draw it in 3 dimensions, it just becomes this magical convergence, and it's just a nonsense.
and that the force of gravity comes from objects bending space-time, making other objects fall in towards them.
So again, it just doesn't. It's just, again, this is so trivial. It's such an error to sit there and say I'm going to explain the three-dimensional universe with this pitiful two-dimension analogy. Now, it's fine to illustrate some things in 2 dimensions that don't need 3 dimensions, because it's the third dimension is going to be doing the same thing as the other 2. But this does not explain what, again, you can't do this as an elemental description and say there's something called a fabric and it's bent, because there's nothing like that in 3 dimensions. There's no way to 3-dimensionally draw your fabric except as a convergence, as like a radiating star with little rays of light coming off, like a light bulb. There's nothing about a light bulb that tells you, oh, those are just bent curves that it's traveling, bent curves in space. No, the sensible analogy is there's a bunch of straight line vectors. There's rays that come from the light bulb, and that's the only one that works, because if you start curving the lines, then the speed of light has to change. So their curved space doesn't make any sense. All these curved lines somehow things travel them in exactly the same amount of time, even though they're going longer distances, and that doesn't make any sense. So it doesn't work as an analogy. It's just, it's terrible physics.
Well, relativity describes the very big. Other physics...
It doesn't really describe anything. It's a pitiful analogy. It's as pitiful as the wave theory of light in the 2-slit experiment. It's fundamentally broken. It doesn't work. It doesn't make any sense. The wave centers are completely in the wrong location. They just don't care that the details don't fit. And they don't fit in a dramatic way. Bent space doesn't fit. There's straight line vectors. Light always travels the same distance in the same amount of time. It's just bullshit to sit there and say it travels some curved path faster or slower than the speed of light.
Physicists were busy at work on the very small in the world of quantum physics. Atomic theory probed the nature of the atom, and more detailed descriptions of the...
So that's the funny part here. He won't give us anything here. So this is all Heisenberg, whatever you call that, superposition. Things are in the same place. Things are in every place. I mean, just nonsense theories. It's 2 electrons are right in the same location. 1 electron is in 5 different locations. I mean, it's just nonsense all over the place. And then the silly thing of entanglement, where there's somehow 2 things on the opposite side of the universe somehow know and communicate with each other and somehow know what condition each other's in. Just absolute nonsense.
Were developed. From a tiny sphere to electron orbits.
So, and again, electron orbits. There's no need to have any of this electron orbit stuff. You can have a magnetic style model of the atom where you put the electrons in tension with each other, attracted to the proton heavy nucleus, and the electrons can just sit in those positions and be perfectly satisfactory. You can still have your orbitals, but they're not orbitals. They're just distances from the proton. And they're distances that are compliant to the charge. So if you build an atom out of charges, you can make one that makes sense instead of this silly idea that somehow there's an electron going 480,000 miles a second, and somehow by some magic it's being held in those orbits by charge, when charge, they know, doesn't work that way.
Energy levels, and then to the electrons being wave-like charge distributions.
Yeah, so again, wave-like charge distributions, like that says anything. This is almost a Ken Wheeler hyperboloid kind of mishmash.
Condensed matter physics describes the quantum physics of many atoms together in solids and liquids.
So again, it's a very weak description, generalizations, and obviously you can make certain generalizations about what crystals will do, and what, how you can layer the crystals, and whether there are purities in the crystals, and so all of that science is legitimate, getting into molecules and chemistry, and sure, go ahead and do that. But that's not quantum physics.
and is where many great technologies have come from, like computers, lasers, and quantum.
So more nonsense that it came from this theory first. It didn't come from the theory. It came from experiments, and they know it. That's the truth. It took 20 years to develop a blue LED, and it took 20 years to figure out what chemicals you dope the silicon with to make one. And it's that simple. Trial and error for 20 years. No theory helped.
Information science. Nuclear physics describes how the nucleus of atoms behave and explains radiation.
So again, they don't have any explanation. They don't know why things decay or how they decay, and they can't even give you as much. They don't even give you as much information as I have just given you. I've said more about nuclear decay than all the other videos on YouTube, in the sense of pointing out that we have clear evidence that decay is not something the atom is doing. It's something the environment is doing. The environment is providing a key ingredient that causes decay. If I change the environment, I change the decay rate. That's fundamental to understanding what decay is. I mean, I always, as a kid, I'm listening to their crap, I had some notion that atoms, decaying atoms could be born at different times, you see, and they'd all last 10,000 years, and then they'd all die when they were 10,000 years old. I had some notion that it was an age, and it was some sort of time thing. And it has nothing to do with any of that. It has to just do with rolling dice, okay, and getting two skull and crossbones, and that's it. So it's some event that happens. The environment rolls the dice, and the decaying element gets whatever the dice roll. But the environment is causing the decay.
Nuclear fission, the splitting of an atom used in our nuclear power plants, and nuclear fusion, which takes place in the sun and will hopefully soon be harnessed here.
Hopefully someday we'll make a container that can take 273 Kelvin worth of heat or something. Yeah, now I don't think you're going to make a container. So, this is just physics in the realm of impossible, in the sense that we can't really make a container that can take the heat that you're going to create. So there's just no point.
On Earth. Particle physics probes even deeper to find the fundamental subatomic particles that everything is made of.
So again, now we have all these subatomic particles, and we know the only players are electrons and protons. Those are the players. All this Higgs crap, neutrinos, all this made-up nonsense, antiparticles, positrons, all of it is all crap. Okay, very little evidence, and very little reasonable reason, and very little logical reason to believe they exist, because they don't have a role to play in atoms. These are all things that they can only find in the most bizarre circumstances. They have to strangle and torture things to get these things to pop out, and they pop out for milliseconds, and so why believe that has anything integral to do with the real physics? None of these things are the real players. There's just electrons, protons, and the forces that affect them. 2 + 2 + 2 physics. Two forces, electron and proton reflective, two pieces of matter, electrons and protons, and two kinds of interactions. Move you straight, move you perpendicular.
Described in the standard model of particle physics. And quantum field theory captures all of quantum physics and combines it with a special...
So this is just more aggrandizing horseshit. Quantum field theory just means that you're just saying, I'm going to account for what happens by giving every point in space that I can build, how much for the space I need to, the space around you, and I'll give every single bit of that space an identity. That is, I'll say it's pointing towards you or pointing away, and then predict what you're going to do, of course. And so it's just the same. It's basically, again, another particle theory, okay, in the sense that it's just quantizing space, which is the same thing as just quantizing the force that's in the space. And obviously I would argue this space quantization is too regular, that the real forces come in rays, and that there's places where there's a lot of them, places where there's few of them, that kind of thing. So there's no even distribution. There's lots of places in space where there is absolutely nothing. No little bit exists in that little piece of space. But it doesn't really matter. The point is Their quantum field theory is really a particle theory. It's really saying kind of overtly that the quanta, the force, is in positions, and those positions have a vector. That is a place where that force is moving to next. There'll be a position that checker is going to move to, and it's either coming towards you or it's going away from you. And whether it's coming towards you or going away from you is going to decide whether you're going to get moved by it or not moved by it.
Theory of relativity, and it's the best description of the universe we have.
And it's basically, again, a particle theory. And it doesn't describe anything. So again, they just so aggrandize this stuff. It only explains anything if you can explain what every single bit is in the whole, the whole blackboard around you. It's really just saying that if I give me all the information available, and I can make a prediction. Well, of course you can if you have all the information, but you'll never have all that information about any circumstance that ever takes place. Even in the visual universe, it's hard to keep track of all the little bits that are in this environment. I can't calculate the gravitational influence of all the little crap on my desk right now. There's no way to even do it with a supercomputer. I can't even calculate that. So why say that you have a theory that solves when it can't solve?
Unfortunately, quantum field theory doesn't include gravity, and so
it could include gravity. You just decided not to make it include gravity because you think this other theory is right. So there's no reason why they can't put it in the field, but then they have to make it real. And the problem is when they make that little piece of gravity real, then they have to account for how they can plow through it. Then they have the drag issue. See, by having bent space, they evade having a real force. And by evading having a real force, they don't have to account for velocity through their ether. That's why they never say the word ether. Because they can't concede it exists, because then they have to explain how they can plow through it without being slowed down, yet it can push against them. They'd have to explain why they don't push against the ether, but somehow the ether can push against them. And they've evaded that subject by making it synthetic, by creating this plastic fake mechanism. It's just a way of evading the consequences of what creating a real piece of momentum would cause. If they quantize gravity, then they have to explain drag. And they're afraid they can't do it. I can do it. But they're afraid of the challenge.
Physicists don't know how to join together quantum physics and the general theory of relativity, leading to the giant chasm of ignorance.
Yeah, and it's just a giant chasm of reality. The fact is you have gremlin theory versus pixie theory, and the chasm of reality is in the way because neither one of them really is a good explanation. Your wacky verse doesn't fit with your consistent verse. The explicit rules of relativity don't fit with the wavy rules. There's no waves in relativity. Even gravitational waves are rays of force.
One day in the future, we hope to close this chasm and come up with a theory of all of physics.
So you just get the right answers, okay? So there is no separate physics. So there's, this is the whole problem from the beginning, is this segregation of physics into these different forms. To create gremlin theory, pixie theory, hobgoblin theory. That was wrong from the very start. It's one theory of reality. There's no Sasquatches. There's none of this other crap. There's evolution. And what you need is a evolution-style theory of physics. And that is just having the simple understanding that there's forces moving the speed of light that are indestructible. The speed of light, they're indestructible. They can follow them throughout their whole history in the universe. And likewise, the electrons and protons are just moved by that force. And that's it. And those interactions are what creates what we say as change.
We call it quantum gravity. And there are many attempts to do this. Some examples of string theory or loop quantum gravity.
None of these are mature ideas. None of them can survive any of these tests where they have to explain drag and all this other stuff. They're not even big enough to even ride close to anything more than a miniature horse. They'll never get on a real pony or a real horse. So they're so immature and incomplete. And because they look pretty in some way, I don't know, pretty to who, they hold them as some sort of real chance, but they have no chance at all. They're just loop-de-doo. They're just trolls. They're just some other fake boogeyman theory.
But quantum gravity isn't the only thing we observe but don't understand. There are also the major puzzles of dark energy and dark matter.
So these are not puzzles at all. The puzzle is that the universe is maybe changing through time, and the environmental circumstances change. So some constants may not be constants after all. Over a long period of time, maybe gravity changes. Maybe how much force is on the outside versus how much force is on the inside. That is how condensed matter is. The more condensed the matter, the more force it's using up, the more energy. And as that happens, it's consuming energy from only one place, the outside. So the outside gets weaker as the inside gets stronger. And the fact is that can explain all of this crap, the aging of galaxies. The fact that they start off very small and bright, and they get big and less bright.
Seem to make up 95% of the universe, so all of our physics only really describes 5% of what we know about.
So again, right there, he's laughing a little as he's saying it, because it is such a silly thing to say. 95% of the universe is some imaginary crap that we can't even imagine. That's what he's basically saying. It's double gremlins and triple gremlins and big fat gremlins, and so most of the universe is other gremlins. We haven't even told you about those gremlins yet. It's just a silly thing to say.
And everything else at the moment is a mystery. And there are many other mysteries out there, like the Big Bang, and no doubt there's...
So again, why would we be mystified? We would be surprised that we don't understand something that might have happened 20 billion, 40 billion, 100 billion years ago, and we don't have a detailed map of the cause and effect of that universe. What a profound mystery. No, there's nothing profound about that mystery.
Things beyond that we don't even know that we don't know.
Who cares? We don't need to know, frankly. We know the mechanism, just as we don't know the exact mechanism of abiogenesis, the exact transition from chemistry to biology. Yeah, we don't have exactly every detail in line and every bit of that whole cause and effect figured out, but any reasonable person knows it's just going to be there's going to be an answer. There's going to be a simple answer, a cause and effect simple answer explaining how the chemistry accomplished the task. It's not going to involve God and angels and pixies.
Which gets to the lofty cloud which floats over all of physics, philosophy. Although many physicists make fun of philosophy, it's the big philosophical questions that motivate a lot of physics, like...
Well, that's a big mistake then. I mean, the only thing that should be motivating you is the desire to understand, period. And again, philosophy is a subcategory of physics. It just has to do with the part that isn't material. Value. That's all philosophy really is a conversation about what are the value implications of the cause and effect mechanisms, these robots banging into each other. What are the robots accomplishing? What in this interaction between robotic pieces of matter is consequential? And it could be argued that without the idea of consciousness and the ability of things to be harmed, that philosophy wouldn't have any meaning. If there was no harm to be had, there would be no philosophy necessary.
What is the fundamental nature of reality? How come the universe even exists? Do we have free will if we're just made of...
Oh yeah, well those are all dead subjects, frankly. Free will is silly. Free from what? Education? You know, I am free to speak English even if no one teaches it to me. I don't think so.
Physics. Well, how do we know that the way that we do physics and science actually gets to the fundamental truth?
Yes, exactly. You don't do it well. You don't even understand the scientific method. You preach, you talk the talk, but you don't walk the walk. You talk this talk about how you have to repeat an experiment, you have to do this, and you have to do that, and you don't do any of it. You know, and it's just a fact. It's not done. Eddington, Allen aspects, entanglement, but none of these have been redone.
Of the universe. And just why is all of physics like the way it is? Well, those are rather big questions, ones which we may or may never answer, but...
Oh, yes, you may never, because you can't get any of this simple frickin' force-matter interaction part. You can't get that right, then you're not going to understand robot, and then you're not going to understand DNA, and you're not going to understand... psychology versus education and logic. And the fact is that all these philosophical questions have logical answers that are easily deduced.
No reason to give up trying. After all, physicists are not quitters.
Oh, they're idiots and religious kooks is what they are. I'm sad to say that if you're a religious kook, you're just the same thing as an idiot. So you are idiots. I mean, I'll say you're well-educated idiots, but that's all you can say. You have some knowledge, but some knowledge is a dangerous thing, as they say, and that's the thing. Partial knowledge, a little knowledge, you have enough to make a mess. You don't have enough to fix it.
And that was the map of physics.
And so he's selling that, by the way. You can buy one of those. Oh, fuck. Anyway, I have once again done my job, and I guess I'll just move on. Yeah, I guess I could open this thing and just, I'll block that asshole just for fun. What the hell is that? I don't want to customize anything, bastards. Give me the comments, please. Sheesh. Oh, it's SK. That's a different guy. So, bro, she's just teaching basic science to people who aren't familiar with basic mechanical physics topics. Well, again, if she's teaching, shouldn't teachers apply some kind of notion of taking things seriously, and the ideas that are involved are kind of critical, like what stuff you know and what stuff they're guessing? Shouldn't they make distinctions between, well, here we're guessing and here we know? Here we have lots of good evidence. Here we have really crappy evidence. And here we completely fake the evidence, like the double slit. You should fucking dickhead. You sound like, well, I don't care what I sound like to you. You obviously you're tone deaf and retarded because you think, like I said, I'll go play one of your videos. How about that? And this video is pointless. Well, it makes this clear point, okay? I'm right, they're wrong. That's one of the arguments being made, clearly. I'm citing real evidence. They're citing bullshit, like detector experiments and other horse shit. And so you can LOL at it, but I'm going to LOL at you into your grave, fuckhead, okay? I'm going to win. I'm going to be on the right side of the heap, or the ash heap of future history. I'm going to be on the right side of that. I'm going to be on the top of the heap, and you're going to be on the bottom of the heap as one of the assholes who just got in the way. Just another piece of ignorant talking shit. You're talking your shit. You don't have any knowledge of these subjects at all. You got nothing. You're just a fucking guitar player, for fuck's sake. A bad guitar player. The video you are picking apart here is obviously meant for kids. Well, it's obviously not. The content really, you have to go back a lot simpler, right? You have to know 2 + 2 mathematics before you can start teaching trigonometry. You do understand that, right? Trigonometry is a high school subject, not a grammar school subject. Should high school teachers treat trigonometry the way she's teaching? Barney the Dinosaur style? But it's cool that it's so obvious to you, I guess. But it's cool that it's so obvious to you, I guess. Huh. LOLO. I don't know what the extra O is for. God damn, man. You're just so full of these wonderful little perky sayings. Go pick on some videos that are talking about real in-depth theoretical topics. The whole point is theoretical physics is crap. It's not in-depth. It's in Lunaville. It's in Pixie Town. Okay, if you want to act like an asshat. Well, the fact is I have taken on all the others, so why don't you give me a suggested video where you think it's good physics? Why don't you point me to one of your other heroes of physics, and I'll point out how they're fucking flat-headed morons. Shit. What an asshole. Anyway. Ha, easy there, cowboy. You might try whipping it out before filling your pants. I don't know. What the hell? I don't know. I don't think it's the cowboy, actually. The cowboy's not even musical. So, let's go. We'll go visit. What the hell? We'll go visit. So again, you just talk shit, shithead. And again, what do you think you're doing it to? You think you own me. You think you're so much smarter, so much more capable of understanding the universe we exist in. I'm saying exactly the opposite to you. I'm saying, fuck you, you're the moron. Talking way past your competence. My face is on. Oh, that's got to be great. Oh, probably commercials. Yeah. He's got 21 views and he has commercials. He's got to have commercials. 21 views. About 9 million people can do that. 9,278,643. Oh, get to it already. Oh, there it is. I'm gonna do falsettos too. Yeah. Yeah, it comes too easy, So why don't you open some books and try to learn something, fuckhead? So anyway, these people are just so obnoxious. That's not what I want. I want this magic button. Yeah, so fuck off. Grow up. Alright, I hate this silly shit approach this women and other humanoids have in general. Same thing is happening when there is training refresher session in my work. Oh yeah, well you have to be taught how to do everything all, Don't stick your finger in your ass and then take somebody's temperature with your finger. And if we got usual photos, well, I don't need all this stuff in the 4th grade. Well, yes, the whole point is that the whole world is running on, this lowest common denominator level. Every subject is reduced to moronic, cliche, stupid symbols. Like, don't cut your head off with a line through it. A guy who's cutting his head off with a knife. And I put a red line through it. Don't cut your head off. I mean, yeah, it's that stupid. All right. So this guy was talking about Miles Mathis being an anti-Semite. Hard to say. He says he's not, but I mean, obviously he's obsessed. I don't know why he's obsessed with who's the Jew, but yes, he just can't. He has to out all the secret Jews. It's just too stupid. Anyway, their ancestors. They had an ancestor that was Jewish. Somehow it means something to everybody. It should mean something. Everybody has to be aware. And that's just too strange an obsession. Yeah, not to think it's nefarious. I mean, obviously there's this reason to think that's kind of nefarious. When somebody's obsessed about whether somebody's Jewish, well then, yeah, that's sort of nefarious. There's a reason to believe that might not be a good thing. They're not worried for a good reason. They're not obsessed for a good reason. I should put it that way. Anyway, enough of the video. Get the hell out of town. So, till the next time and such and so forth and whatnot. I just wish that icon would show. I have to fix that.